Welcome to the ArcGIS Runtime SDK for Xamarin, an introduction session. My name is Rex Hansen, product manager for ArcGIS Runtime. I'm joined by Rich Swap, who's our lead developer for the ArcGIS Runtime SDK for Xamarin. And we're going to walk you through next hour and 15 minutes of the product that we know as the ArcGIS Runtime SDK for Xamarin. So a brief agenda, just to get an idea of what we're going to be covering. I want to talk a little bit about the Xamarin platform, just an overview of what Xamarin means at this stage. For those of you who haven't dove in yet or haven't experienced Xamarin yet, or maybe have, but are looking for more of a brief description of what the contents are, what it contains, and what it can do. Then we'll dive into ArcGIS Runtime and the Xamarin implementation and how it impacts or how it works together with our .NET development story. For .NET developers with the ArcGIS Runtime for native application development. A couple of the highlights, what we've actually enhanced recently in our latest release, and a release schedule so you know when to expect to get the product, as well as a action-packed demo, actually, to wrap up the session at the end so you guys can see this actually in action. So first slide, Xamarin Overview. What is it? I want to give something kind of a brief overview of what to expect with Xamarin as far as the platform. Think of it as a software suite designed for cross-platform .NET development. Right? So it's designed to enhance the .NET developer's experience to be able to work with non-Windows platforms generally. Right? And so it includes a set of native libraries to support iOS and Android platforms. It's built on top of Mono, which is really an open source .NET implementation for non-Windows platforms, including iOS, Android, Linux. There's a set of platform bindings that are designed to map between or surface these native API calls that are available within non-Windows platforms to C#, specifically to the language C#. Right? And so Xamarin includes these bindings to be able to map that functionality, those low-level native calls to a C# developer. There is also a component called Xamarin Forms. And Xamarin Forms is really an abstraction UI layer that enables you to take advantage of a common UI framework on which to build different platforms. And so Xamarin Forms as a cross-platform UI library gives you the ability to build out one UI that will be skinned for or feel immersive on iOS, Android, and Windows. A set of development tools that are also included with Xamarin components include Visual Studio extensions, to be able to integrate this within Visual Studio, generally 2012, 2013, and 2015. On Mac platforms, we have support for development using Xamarin Studio for OS X. And so if you happen to be developing on Mac and you're looking for an example or looking for a developer tool that would support your ability to work with Xamarin or Xamarin development environments on Mac, you can choose Xamarin Studio. Great, so now we know what it contains. Well, what can you do with it? Well, to put it simply, you're going to be building apps for iOS, Android, and Windows using .NET. Ideally, you've got the same .NET API surface that you're targeting. Your business logic that you're building within your applications can be the same. Your UI might be different depending upon what you need to accomplish within the UI. But generally, you're sharing code across platforms. You're writing it once in C# and you're sharing it across platforms. You're still able to leverage those platform-specific capabilities. The native APIs are exposed in a way that enable you as a C# developer to be able to take advantage of and interact with specific capabilities that are inherent to that platform. But generally, you're building out, much of your code is going to be shared. It's going to be written in C#, and you're going to be able to share that across different platform targets. That's the power of Xamarin, basically. There is as I mentioned before, there is a way to actually build out a UI that shares a common framework using Xamarin Forms. That's the goal of Xamarin Forms, is not having to build different UIs for different platforms, be able to build one UI and have that share and feel immersive across multiple platforms. And so Xamarin Forms and being able to use the markup that is Xamarin Forms XAML and share that across multiple platforms is key. Now note it's a different XAML stack, so it looks similar, but it is different than the XAML stack that's included or supported by Universal Windows Platform apps or WPF apps. Right? But very similar if you're familiar with working with XAML as far as UI markup is concerned. So what are some of the advantages here? I've touched on a few of these, but we'll lay them out in one slide. A large amount of your code is reusable across all platforms. So some estimates would indicate somewhere between 60 to 90% of your code, if you're using traditional development practices, building out your application and using an MVVM architecture, that your model and your view model will share close to 60 to 90% of its code across multiple platforms, right? So you're able to share logic, functionality, and make a consistent business experience actually within your applications fairly easily in a familiar language like C#. What's notable here is that all the platform capabilities that are native to the platform you're choosing are available, right? So they're still there. It's just that you'll need to know or need to figure out when you need to make specific calls to work with platform-specific capabilities, right? So if there's something that's available in iOS only, there's an API. That API is wrapped. It's part of the native API that's included or associated with iOS. There's an iOS binding on top of that. You can access that specific functionality through C# and you can proceed. There might be some if-defs in your code, but inevitably a vast majority of your code, like I said, estimates are anywhere between 60 to 90% of your business logic will be shared. One of the benefits is that the UI components, because you're building on the native APIs themselves, render with a native look and feel. They feel immersive. On iOS, you build an app for iOS, you target iOS, it feels like an iOS app. You build an app that targets Android, it feels like an Android app. You can build apps that look the same on all platforms, but it takes some effort, right? It's possible. Advantages, if you're a .NET developer, and there's a large .NET developer community out there who's been building applications for a long time. One of the struggles for .NET developers has been, how do I take advantage of some of these newer, more popular mobile platforms, like iOS and Android, and how do I leverage some of the power of one of the best IDEs on the market, Visual Studio, and one of the cleanest languages to use and most understandable languages to use to build apps, C#, to build out mobile applications. And that's where Xamarin, a major Xamarin advantage, comes into play. You've got a lot of investment, time, and money into development teams or your own knowledge in how to build out and use Visual Studio and .NET and work with C#. You can leverage that to target some of the most popular mobile platforms today. Xamarin also includes an extensive developer community. I have to admit, in all the technologies I've worked with over the past couple of decades, it seems like Xamarin has a persistent, active developer community, and they're eager to make sure that things work. Now, the fact that they've actually been purchased by Microsoft, which is great, it hasn't changed how they work, right? They're still an active development community. As a matter of fact, it's made it more pervasive than if they were still separate from Microsoft, if they were just a partner. So right now what we're seeing is this integration of Xamarin, its technology, and its developer community within the larger .NET development community. So extensive developer community, a lot of willingness to help make this work. Also, there's been a variety of, there's quite a bit of Xamarin itself as a development technology has been quite nimble. Rapid updates to technologies and capabilities associated with the platform have occurred and will likely continue to occur to make sure that we can keep track or we can keep up with the different platform capabilities that are available in platforms that are targeted by Xamarin. So what we're seeing is rapid updates within Xamarin to match some of those capabilities. And the last part here, which is new since last we spoke about this at the Developer Summit earlier this year, was it's integrated with Microsoft developer technology. Microsoft purchased Xamarin and its technology. It's being integrated into Microsoft's developer suite of products. It's available for free today. If you download Visual Studio Community, you can use Xamarin free of charge, depending upon whether or not you qualify as an enterprise or not. Depends on how much you're paying. But generally, it's available for free. It was cost prohibitive for a lot of folks prior to the acquisition by Microsoft. But now, because it's available with Community Edition of Visual Studio, great. A lot of folks can handle that entry point and build out and use Xamarin more easily than they were before. And so that integration with Microsoft's developer community and cleaning up the story associated with cross-platform development with respect to .NET and Visual Studio is ongoing. Actually, we begin to see some of those technologies assimilate, drop off, or come together as we'd hoped. So it's great to see that work. So that's just kind of an overview of the Xamarin, the technology, the platform, the suite of products that make up Xamarin today. Now I want to talk a little bit about Xamarin and the ArcGIS Runtime. So obviously with the ArcGIS Runtime and native application development and previous products prior to ArcGIS Runtime, there's been a lot of interest at Esri with Esri Developer Technologies in building out solutions on Windows and .NET technology specifically. Whether you're working with map objects, or you're building out an engine application, or you're working with the ArcGIS Runtime SDK for WPF, or Silverlight, or the Runtime SDK for .NET today, there's an interest in providing a solution that enables .NET developers to take advantage of native application development. So what we're going to be able to do is take advantage of that and take it to the next level. Enable our .NET developer community, which is extensive, to work with iOS and Android. So some of the capabilities of ArcGIS Runtime, if you're not already familiar with ArcGIS Runtime, there's a few key capabilities. One is working offline, being able to work with local data. Right? This is critical, being able to use your application, your device, in the field or in a disconnected workflow. And then being able to connect up at some point later and sync up those changes that you've made when you're in the field, or being able to provision or update that information effectively, and then utilize that and take advantage of the local capabilities that are on the device. There's a native user experience. So we're building out an API that supports the ability to look like it's an immersive app if you choose to. And so being able to match other conventions that are associated with the UIs or user experiences that are available for those devices. So we're looking to match that. And then access native APIs. So being able to work with device capabilities, a graphics card, sensors that are on the device, to be able to leverage those to the greatest extent so that you can build a highly performant and responsive application that's critical across the runtime. What about the ArcGIS Runtime for courts? Right, so the ArcGIS Runtime has gone through a number of release cycles. Right now we're at the 10.2x release cycle, 10.2 and then a number after that depending upon which product you're working with. With the ArcGIS Runtime SDK for .NET, it's 10.2.7. That is the current released generation of runtime. Now we're looking at the first release of the next generation of the runtime. Right? So this first major release of the next generation of the runtime has been codenamed Quartz. What we're looking to do with this is refine the runtime so that it works more cohesively in concert with the ArcGIS platform and the capabilities of that platform, whether it's something that's part of ArcGIS Online, or it's part of ArcGIS Server, or it's desktop, being able to work more consistently and more coherently with other products that are part of the platform. And those new capabilities that are brought into that platform, something such as, let's say, vector tiles, and being able to accommodate for that. So in order to do that, we have had to change the APIs a bit, right? So there is going to be a change in our next major release, codenamed Quartz. So we need to keep that in mind. So if you've been working with a runtime thus far, there is going to be an API change actually in the next release. Now granted, with the Runtime SDK for .NET, it was, the design is fairly similar, so it's going to be less difficult. For the other runtimes that have been around a little bit longer, it might be a little more difficult, but the bottom line is there's going to be a rewrite involved when going from 10.2x to Quartz. What we are looking to do, though, is improve the architecture and make it more consistent across all the runtimes and make it more integrated with the platform. So as part of supporting that platform, what we'd like to do is start supplanting some of the older applications that are out there that may have been built with older technologies. Map objects is still floating around out there, and people are still using it because they can build solutions today. Engine is still out there. It's quite, the capability of ArcObjects is quite deep and quite broad. That what we'd like to do is build a runtime that can supplant that, right? That can take its place. That's an effort ongoing right now. In addition to synchronizing all the APIs across the ArcGIS Runtime, we're also looking at trying to support specific workflows that integrate within our platform, such as being able to provision data for offline use, or being able to package up a map and take that offline. But bottom line with the ArcGIS Runtime SDK for Xamarin is we're looking to enhance the .NET developer experience. We have support for Windows desktops. We've had support for tablets and phones. But in following Microsoft's lead in working with Xamarin, we want to be able to provide and we want to be able to support the .NET developer experience for runtime across the board. So great. So we have a couple of different runtimes that are available today. We can see at 10.2x we have a runtime SDK for .NET that supports store, desktop, and phone apps. Right now, what we're looking to do, because Windows Store and Windows Phone are on an older architecture, is we're looking to support. There we go. We're looking to support at Quartz, which the version number happens to be 100.x. Looking to support Windows Desktop still, which would be WPF, and Windows UWP or Universal for desktop and mobile and embedded Windows platforms, but also advancing that or enhancing that to support iOS and Android. Right? So this is our .NET developer experience for Quartz, actually in targeting these different platforms. So what does it look like? What does the stack look like? Right? So runtime for .NET developers. Well, across all runtimes, we have the same common core. Right? It's written in C++. This common engine behind the scenes is native. It's got a couple of different, I've listed here a few, the rendering pipelines that are associated with Windows and non-Windows platforms, such as DirectX and OpenGL. A vast majority of the logic that takes place in the runtime happens here in the shared engine, the shared runtime core. We built on top of that really a managed layer that gives us a common .NET API, right? So we have a common .NET API for non-UI objects, right? So what do those look like? Well, map layers, tables, symbols, renders, geometry, and such, right? A variety of different types, classes, objects that exist in managed space. Now on top of that, we've actually got, for .NET developers, we're supporting WPF and UWP, right? So WPF for Windows 7, 8, 8.1, and 10 desktops, and Windows UWP for Windows 10, Universal Windows Platform, right? And they're built on top of two different .NET frameworks, which are being wrapped and targeted from our .NET API. Now this is actually where we have our UI logic. So this might be where you have your, this is a lot of your view controls, which would be working with your view model, which is behind the scenes and leveraging a lot of what's in our .NET API, our common layer, right? The common layer in our stack of technologies. Now, as part of this, as part of the ArcGIS Runtime SDK for Xamarin, we're building this on top of the non-Windows implementation of .NET, so mono.NET. And we're building on top of our common .NET API layer and building out a way to render content controls within iOS and Android. Right? So being able to provide a map view and a scene view, controls that render for Android, leveraging the iOS and Android bindings that are part of the Xamarin platform. And then on top of this, we've got a thin UI layer that supports forms. Right? So the ability to provide really an abstract UI that will support, or that you can use to target iOS, Android, and also UWP as well. So this is something that we support today in our current beta release. Right? So the key here is we've got a common native core in our C++ engine, runtime core engine. We've got a common .NET API at the managed level. And then we have some differentiation there at the UI that are provided, and there's an example of some of the controls that we do provide today to enable you to leverage some of the differentiation in the UIs. Right? So we have some shared logic there across the runtime for .NET developers. So what are some of the things that we include in the ArcGIS Runtime SDK today? APIs for iOS, Android, and Forms. Right? So we support, if you want to be able to support traditional Xamarin development by targeting iOS and Android, we support that. If you want to be able to leverage Forms to be able to target multiple platforms and have a common UI, we provide support for that. What's new, and I've highlighted here, is support for UWP. In our latest release, you can target UWP. You can build an application that leverages Forms for the UI, and you can target UWP. That will work. It's all still one common .NET API surface designed for high-performance 2D and 3D display. Now, recently we just added support for 3D. So if you want to be able to build an application that shows your data, your three-dimensional data, or your data in a 3D context, you can do that for iOS, Android, Windows. Right? You can use Xamarin and .NET and the .NET development environment with ArcGIS Runtime to do that. Obviously, as with every Runtime SDK, we need to be able to work with online services and content. So that's a no-brainer. We need to include support for that. And also overlay transient data, such as graphics or information that needs to be available. So there's support for that too, as well as being able to query data that's present within those online services or local, and enable the ability to work with our portal, whether on-premise or in ArcGIS Online, to collaborate with some of those changes. And we also support the ability to work offline, right? So we can work with local maps, mobile map packages. We can work with local data. We've enhanced our data support in the latest release to support local rasters, KML, right? So you can work with that today in .NET across all platforms. Local search, routing, and analysis, still there, still working offline at this stage. And most of all, this is a runtime SDK. It's designed to work with, designed to build native applications that you can integrate with your resources on your device, right? Be able to utilize local sensors and integrate those within your application. Great, so I announced a few things there that are available in Runtime today. So what's actually available, right? What's the release schedule look like? Well, we had a public tech preview of the ArcGIS Runtime SDK for Xamarin in late March. We just had one last week, the ArcGIS Runtime SDK for Xamarin and the ArcGIS Runtime SDK for .NET, right? So that entire stack of technology that I presented a couple slides ago is available today, and is available on our, as part of our early adopter community for free. All you have to have is a login. You log in, you can download, you can start working with it today. The first commercial release of both, of all components, including our Xamarin support, is currently scheduled for November of this year. And so we're looking to release that so that you can go into production with those components at or after that time. So how do you get started? This is an introduction, actually. So how do we get started? Well, join the public beta. If you go to our website listed here, developers.arcgis.com/Xamarin, it's going to take you to a landing page. One of the first buttons you see there is Join the Beta. Click on Join the Beta. If you already have a login, an ArcGIS account that you can use to log into the early adopter community, great. You'll log in. You'll see a landing page. You'll see a download, and you'll see a forum. Download the product. Start working with it. Explore the documentation and the samples that exist as part of the developer site, or go to the forum to ask questions. We have a quite active forum out there for getting feedback, and our development staff, our development team is actively watching that forum and trying to answer questions as they come in. And then at that point, once you're ready, use your content. Start working with your content, start working with online content, upload your data, start creating content, start creating maps and working with those maps, using our desktop products, using our server products, and start integrating with it, right? Nice, easy way to get started with Xamarin today. So without further ado, I'm going to pass this off to Rich, and he's going to walk us through the current release of the ArcGIS Runtime SDK for Xamarin and show off some of its capabilities. Great, Rich.
Thanks, Rex. So what I want to do with this demo, since a lot of you guys aren't necessarily that familiar with Xamarin at this point, I want to give you an idea, just build a simple app to kind of show you what it's like to work with this tooling, what it means to actually build out this cross-platform iOS and Android application, and how you can really reuse the .NET knowledge you already have. And while I'm doing that, I'll touch on some runtime functionality here and there, but my focus is not so much to build out an elaborate runtime app as to help get you guys started building apps with Xamarin that incorporate our Runtime SDK. So here I am in Visual Studio. Since most of you guys presumably are .NET developers or have .NET development experience, this is the IDE of choice. It's the same thing when you're doing development with Xamarin's platform. And here you can see I have a Android application over in Solution Explorer on the right. I have an iOS application, and then I have a shared project. So that shared project is referenced in both my Android and iOS projects, and this is where I'm going to have all that code that Rex was talking about that could be reused, that 60 to 90% of business logic, view models, service classes, those kinds of things can just be completely reused cross-platform. So let's start there in my view model layer and see what we have. So you can see I've got a map view model class open, and this implements iNotify property changed. That's probably familiar to all of you guys. That's just standard MVVM stuff. I implement iNotify property changed. That gives me my property changed event. That gets called to notify my view layer. Hey, view layer, something's changed here on the back end. Would you please go and update yourself? So in this map view model, naturally, I have a map property, public getter, private setter. In the setter, I'm calling that property changed method. And then in my constructor, I'm just initializing that map for the view level of my application. Now the map here, if you're familiar, if you've used ArcGIS Runtime SDK for .NET at like 10.2.6 or 10.2.7, then you're familiar with the map being a data object. It's a data component. It defines the configuration of the map you want to show in the UI. It's not a UI control in and of itself, so therefore it's back in our view model layer. So here, I'm newing up that map, and here I'm actually touching on a little bit of an API endpoint that's new to Quartz. I can pass a base map to my map constructor. The map data object is at Quartz. We split that into a base map and operational layers to make that distinction clearer. And then I've just got a convenience method to pull down the National Geographic ArcGIS Online Map Service. Fairly simple stuff. Okay, so there's my view model. Now, how are we going to push that down through into our iOS and Android view layers? So here, I'm going to jump over to this main.storyboard file, and this is in my iOS application. Storyboards in iOS are essentially your UI definition. If you're familiar with Windows XAML-based development, this is kind of the equivalent of the XAML in your user control or your page, right? The difference being on iOS, you don't actually hand edit the markup. It's all done through a designer. So you can see I have a map showing here. And now if I jump over to the view controller, this is essentially the iOS equivalent of your code behind. So here in my view controller, I'm instantiating my view model. Then I'm just grabbing the map off of my view model and pushing that into my map view. So that's the UI component that's the UI side of my map, and that's down here in my view layer. So that's iOS. So it's going to be a little different here then for Android. Here for Android, I've got a main.axml file. So once again, this is the Android equivalent of like a XAML page or a storyboard. This is something called layout XML in Android. You can see I have a designer that kind of gives me an idea of my how things are arranged in my UI. But then on Android, unlike on iOS, I can also go in and hand edit that markup. And this is a pretty simple XML-based format. This isn't anything Xamarin specific. This is actually the same markup that an Android developer would use. It's a little bit like XAML, except it's actually not nearly as cool. And by that I mean it's really just for defining how things are going to be arranged in your UI. In XAML, you not only define how things are going to be arranged, you can actually fully specify all the properties of your objects, and then you also have data binding to push content up to your view model layer and then to get notifications back down from there. You don't have that in layout XML in Android. So then that's our layout. Then we have our activity. This is kind of the Android equivalent of our code behind. So here again, instantiating the view model. This find view by ID is just how we get the map view out from that layout on Android, then push the map back into the map view. So let's run this on iOS and Android and just see what we have. So I have the iOS project as my startup project. I've just pressed F5 to run that. And just like that, it's all, except for that storyboard and that layout, this is .NET. It seems, looks and feels, smells like .NET code, right? And it's running on iOS. And switch over to Android. And F5 again. And just like that, we have our map with that National Geographic map service, right? Okay, so I mean that's a pretty trivial example just to kind of orient you to how the architecture is. So let's build this out a little bit. So what I want to do is actually give my user a drop-down to switch between different maps or different base maps. So what do I need back in my view model layer for that? Well, I'm going to pull in this base maps property. This is just an enumerable of ArcGIS portal items. Now these are ArcGIS portal items because I want to get the set of base maps from ArcGIS Online. I'm going to get the base map gallery from there, and I want to expose those to my end user. And they're called ArcGIS portal items because they're not only from ArcGIS Online, those can also come from an on-premise portal. They're interchangeable. Now, I also want a property that indicates which among that set, that universe of base maps is currently selected. So for that, I've got just, instead of an enumerable, just a single portal item, base map item property. And this is pretty much standard getter and setter, except in addition to firing my property change notification when I set it, I'm also going to update my maps base map with that newly selected portal item. And here, to initialize that base map, I can actually just pass it the item I've gotten right back from ArcGIS Online or from my portal, and conveniently just make that change. Now I also need a way to let my view know, since this is an asynchronous web request to get this list of base map items, I need a way to let my view know when that request is complete and when initialization has happened. So I'm just going to pull in this simple isInitialized Boolean property. That's going to fire my property change notification and let my view know that it's okay to display those base maps. And then I'm going to stub out a little method to actually do my initialization logic. There's some asynchronous calls, so I don't want to do that into constructor. I need to split that out into a method with the async modifier here. Now notice, I'm sure you guys are using async await in your Windows applications. Just because it's Xamarin, that doesn't mean our syntax is any different. We still have that nice, convenient syntax for asynchronous functionality. Now I've got that stubbed out. I want to actually bring in the logic to pull down my base maps from portal. So I have my portal, in this case ArcGIS Online's base map gallery query. So I'm grabbing that, grabbing the results from that, pushing those portal items into my base map items property. So there I've got my universe of base maps. Then I want to actually initialize which one's selected from the start of the app. So I'm just going to, using a nice little link query, again, that nice syntax we're all used to from C# .NET development is still available, even though I'm targeting iOS and Android. I'm just going to grab the base map that has a title of topographic, that's the world topographic map in this case, and set that as my initially selected base map. Then just set the extent, new up my map with my selected base map, and we're initialized from the view model's perspective. So now we need to push that update back down into the view. So I'm going to focus on Android for right now to do that. So here back in our activity, remember that's kind of like our code behind on Android. I'm still instantiating my view model, and then I'm going to listen to my view model's property change method. And I want to do that so I know when my view model has been initialized, when it says it's initialized. And it's going to do that, of course, like I just explained, once we get all our base map items, right? So here I'm just going to check that the view model is initialized, check that the property that's throwing this event is actually the initialized property, and then basically like I had before in the onCreate method, I'm going to get my map view, push my view model's map into that, and then we're initialized there. But, so that's initializing the set of base maps and the initial map. I still haven't brought in my base map dropdown, right? So here I'm going to jump back into my layout XML. So this is my UI layout, my UI arrangement. And I've got some more Android objects. So I've got a linear layout. This is basically like a stack panel. In this case, it's horizontal. Just have a base map label, in this case, a text view, and a spinner. That's kind of like a combo box. So it's a little bit of a different UI lingo, but you can see it's kind of analogous to the sorts of things you might be familiar with. And that's really where things diverge, right? So now I have my base map initialized there. I have my base map picker. Now I need to actually initialize the items in my base map picker there. So here's just some more Android-specific stuff. It's basically just getting my set of base map items, converting them to a string, plugging them into the dropdown. And then I have my item selected event there. So that item selected event, as the name would suggest, is going to fire when my users actually selected something from that dropdown. And of course, when they do that, I want to update the map, right? So let's bring in that event handler, and then we'll explain a little bit what's going on there. So I have my item selected event. User picks a different base map from the drop-down. Then here I'm just getting the index that the users of the item that the users selected from the drop-down, getting the base map that matches that index, and telling my view model, hey, that base map item is now the selected one. And if you remember, in the setter for that, then we update our map's base map, so then that change will push down through my view model, and my view already knows about the map, so it's just going to get that update, right? Now that might seem, oh, I forgot something. Let's do this. So I have this initialization logic, right? My initialize method, I should probably actually call that. So let's do that. Anyway, that kind of sequence of events, all this updating from the UI, then back in the code behind, then up to the view model and round tripping back down, that might seem a little complicated or maybe not complicated, maybe a little tedious to wire up, right? But that's basically, if you're familiar with data binding, that's kind of what data binding does for you. We're just being more explicit about it because data binding doesn't exist here, right? So here now you see we have our base maps picker, and if we select a different base map, off we go. It works. All right. So that's cool. Now I want to add a little more, make this a little more functional. I want to allow my user to search for places in the vicinity of the map area they're looking at. So now I've drilled in and given you kind of a sense of what the process for building this functionality out looks like. I'm going to just fast forward a little bit and bring in an almost completely finished view model. This is called the find place view model. Of course, this is going to provide for my application the capability, the functionality to search for places. So on this, I have a couple methods of interest. I have a get place suggestions method and a find place method. So when my user searches for places, I don't want to just wait until they have a completely completed input and then just go and geocode it like user-friendly apps do nowadays. I want to give them suggestions of places they might be searching for as they enter in text in the application, right? So now this is something that's new to the Runtime API at Quartz. You actually have the ability to do that directly from within the API. So let me just grab a little code snippet here. And here, this is off of the locator task. If you've done runtime.NET development, you're already familiar with the locator task, same object, but now we have a new method called suggest async. And that's going to take my search text as well as the proximity within which I want to get suggestions for. And then as far as searching for a place, that's pretty similar to the way I might have done it at an earlier release of the runtime, except now my user's gotten a list of suggestions, and they're going to pick one of those suggestions. And those suggestions at the API level come back as an object called suggest result. Well, what do I do with that? So we have an overload now. Again, we're still in locator task, geocode async. It's a method that was there previously. But we have an overload, another version, that actually will take that suggest result that you've just gotten back from that list of suggestions. You get suggest results, user chooses one, then you can pass the one the user chose back to the locator task, and it'll give you the precise location back. So just a couple little API enhancements there. So now that's our view model. We need to pipe that view through down to the view. So I'm going to bring in another Android-specific object here called Autocomplete text view. As the name implies, that's going to provide auto-completion suggestions for my user as they type. But there's going to be some code in my code behind here to get that working. Just to fast forward, I'm just going to bring in the whole thing pre-finished. give that a run, and I need a using statement apparently. Deploy that out. Now I have a bunch of these Android-specific objects, right? And that's a little tricky in some ways, but in other ways, it's really kind of cool that I'm writing .NET code, but see, I have this spinner object, for instance, that's an Android-specific UI object. And as a .NET developer, that's available to me just as though it were any other .NET or Windows platform-specific component. All right, so that's come up. Now let's see if it works. Let's search for Cabrillo National Monument. See, I'm getting suggestions as I go. I pick one, and then I had brought in some logic that actually takes that point and then zooms to it. And now I've gone through and gone through the process of how this is done for Android. I could do the same thing for iOS, but that gets a little tedious, just going through the nuances of how this all gets wired up. So I've already done that ahead of time. Let me just show you how that looks here. So you may have noticed the Android version, it looks and feels like an Android app, right? The drop-down looks like an Android drop-down. Same for the text box. Now here, the iOS version, same thing. It looks and feels specific to iOS. It's the sort of experience that an iOS user would expect. And that's, even though you have this, you can tell it actually is iOS because it has, it does auto corrections that you don't necessarily want, right? Completely native experience there. So while there is this extra work once you get down to the UI layer, you're providing an experience that looks and feels natural to the specific platform that your user happens to be using. But the rub is there is that extra work involved, and you need to learn the different UI lingos involved here, right? So as Rex mentioned, there is an alternative approach that Xamarin provides, and that is Xamarin Forms, right? So here, let me jump over. Oh, that's interesting. So I'm going to jump over to another version of this app that's going to be built out using Xamarin Forms, assuming it'll actually open. Well, it's never good to have it crash, but it's nice that it just went and reopened itself for me. So here in this version, I have that same shared project already. So these are the same classes I already had. They're already all built out. But my Android and my iOS app projects, these are completely new, different projects. And Rex also mentioned that with Xamarin Forms has support for UWP, Universal Windows applications, right? And I've got a Universal Windows application project in my solution here. And then in my, then I also have an additional shared project, this forms.shared project. So remember the one on the bottom here, this is where my view models are. Actually, I guess I'll keep that open to try and minimize confusion over which shared project's which. In this forms shared project, this is actually where my UI is going to be defined. So in the other version of this, in the other solution I had different UI definitions, one UI definition in the iOS project and one in the Android project, kind of parallel definitions. In this one, I actually have three platform-specific versions of this application, but the UI is defined in one place. Even better, this UI is defined using XAML and code behind. So here, if we look at the code behind, I'm newing up my view model, my map view model, and I'm setting the binding context to that. So, okay, so they call it binding context instead of data context. It's the same concept as on WPF and UWP for binding. Then looking at the XAML, this looks like it could just be in a Windows app, right? I've got a grid, I've got my map view, same syntax, I've got my X name, and then I'm using binding to set the map on that. So if we give this guy a run, let me make sure my build configuration's good. So what we should see, we have the same map view model. We haven't built up the UI yet, but that getting the base map items and setting the current one is still happening behind the scenes. So you see we have the same extent around the convention center that we had in the platform-specific versions, and we have the world topographic base map, right? So all our back-end logic is there. Now the question is, how do we build out that UI? So let's take a look at how that actually looks to give you a sense of what Xamarin Forms development is like. So I'm going to bring in some column and row definitions. So this should all look very familiar to you guys. I want 2 columns. I've got a base map label. I've got my drop-down, so 2 columns, 3 rows for my picker, my search box, and my map, right? And then for my actual drop-down, let me bring in a couple XAML elements here. Here I've got a label instead of a text block and a picker instead of a combo box. Like Rex mentioned, they may have different names. That's a byproduct of the fact that they're doing a completely cross-platform abstraction layer, so they take a little from this platform, a little from that platform, and try to meld it together as best they can. But it's XAML. It looks and feels and behaves very much like XAML. And then, last but not least, I need to specify rows and columns on my map. And let's take a look and see how that looks. So there's my label, my picker. It's empty. Okay, so we need to get the items in there. So to do that, I'm going to go in my code behind. And kind of similarly to what I did in the Android version of this app, I'm just going to hook to my property changed event. Wait for initialization, and then actually go through and add the items to my base map dropdown. And then set the selected index of that dropdown to match the base maps that's been selected. Let's run this again. Now, one thing you might notice, I'm running UWP, the Universal Windows Platform version of this. One of the nice things about having UWP support, I don't know if you noticed when I built and ran the Android versions, it took a little while for it to spin up, do all that compilation, and push out to the Android emulator. With UWP, one of the advantages is you can iterate very rapidly. So you see here we have our items populated. When I select different ones, nothing happens yet. It's not wired up. So what are we going to do for that? This, similar to what we might do if we were developing a Windows app with XAML, I've got a selected index changed event. Oops. And let's actually bring the event handler into the code behind. And once the selection has changed, I'm going to update the selected item in my view model. Oh, I guess I'll give that a run. So even if you don't have, even if you're not interested in necessarily shipping a Windows version of your application, it's just kind of a nice development tool to be able to do that. So you can just quickly see that that functionality is working now. Now what about that place search? So here I'm going to bring in the Xamarin Forms version of that, Autocomplete view. And then some wire up and code behind. I've got instantiating my find place view model there. And here I want to listen for when the user's updating the text in my search box. There I'm going to get the current extent that my user's looking at here. Then from my view model, get the suggestions of the places that they might be looking for based on the text that's there, the center of the current extent, and then a search distance around that, and then update the suggestions list with those that come back from the view model. And run again. And hopefully we should be getting some suggestions back, and we are. So that's good. If I click them, nothing's going to happen though. Still need to do that wire up. So back on our autocomplete view, I want to listen for when the selected item is changing, declaring the name of the event handler in XAML, just like I would on Windows platforms. And then implement that event handler in code behind, right? I mean, this should look like a familiar pattern to you guys, even though I'm doing this cross-platform. So in that event handler, I'm just going to get the suggestion for my view model that matches the one the user selected, and essentially just ask my view model, could you please give me the exact location of the suggestion my user's chosen? And once I've gotten that location back, then I want to add it to the map and zoom to it. I'm going to gloss over this a little bit. Pictures in the middle of the session, huh? Whoops. Are you going to tweet that? I did throw off my copy-paste mojo, you know.
I was hoping to get more.
So let's build all of these. Okay, so once we get that location back, then here's some runtime specific code. I'm going to get the viewpoint, essentially the extent plus a little additional information for actually viewing the place the user's chosen. Then I'm essentially going to create a graphics overlay at 10:2x. You would have used graphics layer. Graphics overlay is kind of the Quartz version of that. Then I'm going to create a graphic out of the location that I've gotten back from my view model that, again, has come from the suggestion that my user has selected. Add that graphic to my graphics overlay, and then set the viewpoint on my map view. That's essentially zooming to that location, right? So that's all built. Let's just run UWP first here and see that that works. So now if I search for, let's do San Diego Airport. Cool. So that works. Now, and that's our application's essentially complete, right? And I built this all out, iterating on UWP because it's the fastest turnaround. So let's start seeing what this looks like on other platforms. Start with iOS. There's the non-Forms version of my app. We'll just get rid of those. Build succeeded, deploying, launching. And what do we get? Well, it's the app. It looks pretty good. I've got my base map picker. Does autocomplete work? Let's search for Coronado Ferry Landing, sure. And my UI definition was all in one place, right? So that's pretty good. But there is one problem up at the top here, right? The UI is interfering with my platform UI information about my connectivity and time and whatnot, right? So what do we do about that? Well, Xamarin has actually provided a pretty clever mechanism for dealing with those things. Let me bring in a little snippet here, and we're going to jump back over to our XAML page and paste in this. Here I'm just defining the margin of the root grid in my map page, and I'm saying on platform, the grid margin on platform iOS should have a margin of 20 on the top and 0 all around otherwise. But that's saying it's specific to iOS. So it's not going to touch the other versions of this application. And just with a couple lines of markup, I've created an exception for one particular platform. And just to reinforce why you might like to use UWP to iterate if you're doing Xamarin Forms-based development, as we wait for this to spin up, UWP, I probably could have built it and deployed it 3 times by that point, right? So there. So you see I've got my margin all set at the top. And how's this guy looking on Android? Now, while the mechanism that they've provided for dealing with these sort of things is really clever, it's something you have to be aware of and be able to use and manage, right? Some folks, rather than carving out specific exceptions in the middle of their markup, they might say, no, I'd rather just have 2 different versions entirely. It's just a slightly different way of doing things. Okay, so on Android, we've got our base map picker. So you can see the functionality is working, right? But what's the problem? For some reason, this has black text on Android. That's kind of weird, but we can deal with that. So similar to what I've done for iOS, for Android here, I can come down here to my autocomplete view and say, you know what? My text color on Android needs to be white. So essentially, you can use this, and there's a programmatic version of it too, so you could do the same thing in C#. You can use this on any arbitrary property. So if you need to differentiate between different properties in XAML or in code behind, you do have a mechanism for doing that. So let's see, did that fix it? And it fixed it. So hopefully, I know that was a lot of stuff to run through, but hopefully that gives you guys a good sense of what it's like to do Xamarin development and what the different options are for building out your UI layer, whether you're doing platform-specific native UI development or whether you're doing Xamarin Forms. And how in both cases, I think in my, this is a pretty trivial example, I think in my native platform-specific version, I was probably using somewhere around 70% code reuse, I would say. And then in the Xamarin Forms version, I had literally 1, 2, 3, 4, 5, 6, 7 lines of markup that were different. So pretty powerful stuff. All right, back to you, Rex.
Good to go. Great, thanks, Rich. Yeah, so some great example there, some great examples of how to get started with the ArcGIS Runtime SDK for Xamarin, and then some of the, I guess, the benefits and workflows when trying to build out those solutions, targeting multiple platforms. Some of the benefits in the sense that in many cases you are going to have to consider, depending upon the complexity of your application, some nuances actually in the platform and how to be able to accommodate for those. So that kind of leads into Xamarin challenges. What are some of the things that you'll have to consider when you start working with Xamarin as a .NET developer? So traditionally, if you've been building out applications with .NET, generally you're building for Windows At this stage, because we're working with two different operating systems, two other platforms, there are some nuances in those platforms, and the complication of your application may dictate that you may need to diverge a bit, depending upon what the demands of those platforms and the users that are working on those applications on those platforms. So there could be some platform-specific code, depending upon what you need to do. So something to consider and something to manage that might be different than what you're used to when targeting Windows only. If you're building for iOS, if you're building for iOS, even though you might be using Visual Studio on Windows, you're still going to need an iOS box to actually compile the package that you're going to distribute as your application, right? So still something to consider as far as what's necessary. There's no VB.NET, so if you're a VB.NET developer, there's no support for that with Xamarin, actually, so it's only C# at this point, so something to consider. Xamarin tooling is still maturing, actually. So the product itself is, the foundation itself has been around for a while, but the company founded in, I think, 2011, actually, and they've experienced quite a few rapid updates over the past few years, and we continue to see enhancements in the platform. It's great, but at the same time, because of those rapid updates, you do have to kind of keep pace with those changes as they occur. And there's some of the flexibility that comes with this abstraction UI that is Xamarin Forms still requires some additional enhancements and functionality to really close the gap on some of those needs that are enabling the sharing of that logic across multiple platforms.
And to that point, sometimes you run into quirks too, like you saw with the autocomplete box. The text color was black for some apparent reason, whereas by default the system color would have been white. So that's just an example of some of the things you can run into. It's a monumental effort to actually build that UI abstraction layer on Xamarin's part, but you do run into the fact that there's lots of updates and things are still maturing in places. Right.
So we, as building on top of that, we have to keep pace with a lot of these changes too, which can be challenging actually as far as the rapid updates too. So keeping pace and making sure that you have a development cycle that can support that pace is pretty critical. I have a couple of different bullets here that I'd listed in previous presentations on this context, in the context of Xamarin challenges that are no longer issues. The .NET and Xamarin development platforms are separate, right? So what we've seen now with the acquisition of Xamarin by Microsoft is that we see the development platforms and the suite of technology that's all built together to support cross-platform development come together, right? So Microsoft, in assimilating Xamarin as a technology, has been able to reduce the cost and make it easier to access the components that we know as Xamarin to be able to build those cross-platform solutions. So those platforms are coming together, right? We see some of the integration of Xamarin use, and I mentioned this before, within Visual Studio, and making it available in the Community Edition for free is pretty critical. Also, if you're an MSDN subscriber and you already have an enterprise subscription, great, you can start working with Xamarin today. Actually, there's no additional fee. You don't have to pay another $4, $5, $6 grand per developer just to actually start working with or building Xamarin applications. So pretty critical. So that was actually a cost prohibitive issue. The cost was a prohibitive issue for developers in the past, and so that usually is no longer an issue for folks that are already using Microsoft's development tools. Actually are already members of or part of the developer network with Microsoft. So those are critical things. I wanted to list here that they're no longer an issue because just 3-4 months ago they were still an issue, actually, but they are no longer. Great. Now with that, we're at the very we're at some of the beginning of the week here of sessions. I want to list off some other sessions that might be of interest, just to highlight those. Tomorrow there's a nice slew of presentations that might be interesting. Some are runtime specific, some are actually applied to Xamarin. The first one, beginning of the day, ArcGIS Runtime SDK is building offline apps, talks in general about different best practices or workflows for working with offline data across the board. And because we're building a common runtime, those workflows and those patterns apply to the Runtime SDK for Xamarin and .NET as well. There's a mobile special interest group tomorrow for lunch. Come and get some lunch, free. Actually sit in on some of the demonstrations and some of the work that other partners and customers are doing or building out on the runtime or on our developer technologies for mobile platforms tomorrow. After that, the third one is ArcGIS Runtime SDKs for building cross-platform apps. This is where we talk about different cross-platform solutions in the ArcGIS Runtime. whether you choose to use .NET or Xamarin, Qt, or Java. And we'll walk through some of the techniques there. You'll see Xamarin presented again, different context, as far as an option that we provide for our developer community. Fourth option, optimizing your ArcGIS Runtime apps for performance. Again, because we're building on a common core. This is actually, I believe, a demo theater, and this is actually a pretty critical, highly valued session on understanding how to optimize performance in your applications across the board, and understanding the plumbing and the inner workings of the runtime and how its rendering engine, its ability to access data and utilize that and render that can be taken advantage of. Last one is integrating ArcGIS Runtime with devices and sensors, and this is really this is given by another one of our .NET dev leads, Morten Nielsen, and kind of working with a variety of different devices and capabilities, some IoT devices there as a .NET developer and what he can take advantage of. So that's actually a great demo to take a look at some of the new and innovative R&D that's going on with Runtime. The last one I mentioned is on Thursday. And it's a little bit later, so it's right before the party, right? So a good place to kind of get primed for the party maybe. If you want to learn about what we're actually going to be doing in the future for the Runtime across the board, we've got a slew of presenters actually at our Road Ahead session for the ArcGIS Runtime SDKs. It's a big room, the ballroom. For about 75 minutes, we're going to go through what we're going to be doing in the future. And so that's a great place. We're not really going to cover that here. We're going to let that happen in one place and at one time with respect to the road ahead. So please join us actually for that one. That'll be a great session to find out what we're doing in the future. Now at this point, I want to open up to questions, and I'm actually going to put up our site just in case you guys want to know where to go to get started. I mentioned this before, but I'll just put it up there so you guys are aware of how easy it is actually to get access to the bits today. But I want to open up for questions. I think we've got about 8 minutes, it looks like. Is that right?
Yep.
8 minutes, so we can open up for questions. Yes?
So Rex, I'm actually, we're getting to develop an app, and I was leaning towards Qt because we have developers who have that skill set. But then when I saw your slides, when going from 10.2.x, where all the bubbles are about the same size, and then you went to ports, and the Qt bubbles are really small. You got me worried there.
Why did the Qt bubble get small? That's a great question. I'm just doing this for the recording. Actually, they can hear this. It's because this is a session on the ArcGIS Runtime SDK for Xamarin and .NET.
I thought it was because it was cute. It's small, it's cute.
Right. That's the only reason, right? You noticed all the other ones got small too, but we're not doing away with iOS or Android or Java. That's all still there. It's really just because
focus on what we're
just focusing on what we're talking about in this session. Exactly. It is still a priority. Qt is still a priority, just like .NET and Xamarin are a priority, right? They're all equal, actually. So, good question, though. Yes, other question.
I'm pretty new to Android. I haven't even touched iOS, but when you look at Android, there's very specific ways it handles the activity and driving the life cycle, and certain information will keep in the way it passes information. So when you're looking at Xamarin, is there, I guess, does it somehow integrate with those, or does it try to make its own? I don't know how similar iOS and Android are in that regard. And if they need to try to close the gap there, if they handle their own, like you need to learn the Xamarin lifecycle, how they handle it.
Yeah, so do you have to learn Xamarin's lifecycle, and how similar are Android and iOS to how they handle those things, and how can you do that within Xamarin? iOS and Android are not very similar in how those things work, just like it's not very similar between Windows and Android. I mean, there are some parallel concepts, but there's substantial differences. The kind of the beauty of what Xamarin's done is everything you could do in native Android development, if you were a Java developer building an Android app, you have the same objects, the same capabilities available to you if you're building an app the way I first built out my demo, where you're getting platform specific in the view and the UI in the layer of your application architecture where you're dealing with activities. All the mechanisms you have, fragments, and the way navigation is handled, it's all there. It's all bubbled up to you. It's just that you're coding against it in C# and in Visual Studio instead of in Java and in Eclipse. If you're going the Xamarin Forms route, Xamarin Forms does introduce its own lifecycle events. So you do kind of need to become familiar with those, and they do have their own navigation API. The plus of that is that if you learn that navigation API and you implement it for Android, well, it's also going to work on iOS. It's also going to work in UWP. It also is possible to get platform-specific beyond what I showed in the demo. You notice that there's still an Android app project and an iOS app project and a UWP app project. If you want to add some code files in there that are specific just to those platforms, you still have the option to do that, and you can even do that within the space of a Xamarin Forms application. I hope that answers the question.
Yeah.
That's good. Okay, cool. Yes, the question.
A lot of our customers are still using Windows 7. So does the Android use the Esri or Windows? Could it run on Windows 7?
Right, so great question. So is Xamarin apply to Windows 7? Actually, okay. So right now, if you're building for Windows 7, that's Windows Desktop, right? So our targeted platform is WPF, right? So the slide that I had where it showed the different products or the different UI layers that we provided that really point to different API targets that we actually have within our .NET developer stack. That would actually be the WPF API as far as the UI layer is concerned. So when we have a product, right now the ArcGIS Runtime, at least for the Quartz release, is going to be targeting we're looking at 5 APIs, right? One is for Windows desktops, and that's our WPF API. One is for Windows 10 Universal applications, and that's our UWP API. Another one is our Android, built on Xamarin. It's our Android API and our iOS API built on Xamarin. And then we're also providing a Xamarin Forms, right? And Xamarin Forms is really the thin UI layer on top of UWP, iOS, and Android. Right, and so those are the 5 APIs that we provide for .NET developers as far as with respect to the UI targets that you can utilize when developing. Right. If you're building something for Windows 7, you can still use Quartz. It's just going to be using the WPF API in Quartz.
Right. So if I can add to that a little bit, in the case of to take it back to like what I was building out in the demo. If you're targeting Windows 7, you're using WPF, you could completely reuse those view models in that shared project. But for WPF, regrettably, there is no Xamarin Forms for WPF. Maybe someday we can dream. So your UI layer is going to be specific to WPF. There is no option to do a cross-platform UI that also applies to WPF.
Right.
But all your business logic, the view model stuff, same API, you can share that across, even to WPF on Windows 7.
Right. So what might happen today is that you have an existing Windows desktop application, something you've built in WPF, right? And if you've separated out that logic in a way that you've got your business logic and let's say your view model or your model, and you want to be able to leverage that or utilize that, and let's say a new project that targets iOS or Android, and you want to be able to, as a .NET developer, you want to be able to build out a UI that really surfaces some of that business logic that you have that you've been using in your Windows desktop app. Great, that's a solution that you can look into at this stage because often, obviously, Windows 7's been out for a while, so you might have a lot of existing business logic out there that might be useful actually in new efforts towards building toward mobile platforms. Actually, the same thing would go for UWP as well, right? So, hopefully that helps. Any other questions, guys? Okay, feel free to come on up actually and ask us more if you'd like, more details, but thanks for coming. Hopefully you have a great rest of the conference. Great, thank you guys.